Welcome to this demonstration of Creo, PTC's flagship product design platform with thousands of companies worldwide using it for their various product design needs. In this demonstration, we'll be walking you through a day in the life of a design engineer using Creo and showing off the robust capabilities that make it a mainstay for the design and manufacturing world. The first thing I want you to notice is that Creo is not just a CAD platform, but a full product design suite with tools for rendering, simulation, animation, and so much more, built right into the application. Let's dive deeper into the modeling capabilities first. Creo has a search tool built right in, so even if you're unfamiliar with the name of the tool early on in your Creo usage, you're able to find exactly what you're looking for. We can create a sketch directly from the extrude feature, ultimately minimizing the features needed for modeling and cleaning up your model items tree. We can then finish the extrude by inputting a depth, or by just using the dragger. In Creo, options for surfaces or solids, both adding or removing material, are available in the same menus for easy access. Now that we've made a simple edit, let's delve deeper into the power of Creo's parametric modeling capabilities that allow for a more robust design overall. You can see using this section view that in the front of the impact driver there is some interference between the gray anvil and green carrier parts. Let's fix that. For this edit, we are going to utilize Creo's surface modeling tools and a multi-body operation to create a robust parametric feature that evolves with the model as the design is iterated upon. We can copy the necessary faces into the anvil part, to ensure that if the carrier design changes, the anvil changes with it. We can offset those surfaces to make sure there is ample clearance for one part to fit inside the other. Let's use the dragger to set the offset distance for these surfaces. This workflow, while a bit complex, highlights the parametric nature of Creo and is a great example of the custom workflows that can be implemented to fit your modeling needs. Next, we can use a Boolean trim to create the cutout and fix the interference once and for all. We'll select the correct keep and trim sides, and there we have it, no more interference. To show the parametric nature of these parts, let's make an edit to the carrier and see how the newly edited anvil reacts. If our work has been done correctly, Creo allows these parts to maintain the relationships around the dimensions, and the offset should stay the same. We'll make this dimension larger, and when we go to regenerate the model, you can see that the offset that we created earlier maintains its distance, and the shape holds up as well. This ensures that even if downstream changes affect interconnected parts, Creo allows the relationships between them to be robustly parametric, ensuring design intent stays intact. Now let's look at some of the design communication features Creo has to offer, starting with Model-Based Definition, or MBD. You can see here that Creo has a full suite of tools to add annotations to your models, with the ability to add dimensions, notes, and GD&T in the 3D space, so that anyone viewing the model can have an insight into the tolerancing and dimensions of the part you're designing. Creo also has a GD&T advisor built in to make sure you're using industry-standard practices when adding annotations to your model. We can then create a drawing from the part, utilizing a pre-made template with predefined views. Our annotations from MBD carry over as displayed, and we can add and move them around as needed to create the perfect drawing for our communication needs. We can select which dimensions to use to ensure that our design intent is communicated to manufacturers. Creo's drawing tools make it easy to create and edit drawings, meaning you can spend more time designing and less time worrying about design communication. Next, let's take a look at one of Creo's 3 built-in simulation engines, Creo Simulation Live. CSL allows the user to run simulations easily during the modeling process and get quick results to inform iterations on the design before it passes to a dedicated simulation engineer, who can perform a more sophisticated simulation using another simulation tool in Creo's toolbox. When we make a change, the simulation automatically runs again, and the new stress values are added to the probe graph, keeping a detailed history of key data values. With CSL, Iterate on the design as much as you want without having to export the design and import it into an external tool to get simulation results, speeding up time to production. If we go back to the MBD and drawings that we made earlier, you can see they have been updated with a new fillet radius automatically, ensuring that your different files are always on the same page. Next, let's jump into Creo's manufacturing capabilities, starting with additive. You can create structures like lattices in Creo, allowing you to create sturdier, more complex parts for additive manufacturing. Creo also has a 3D printing tool built into it, where the user can prep their model for printing. You can add multiple models for the same tray, and perform tasks like generating support material, running calculations that validate things like wall thickness and hole size, and preparing and slicing the model for 3D printing, all without leaving Creo. This constant theme of having all the tools you need to go through your engineering workflows right inside one convenient package is why companies around the world are using Creo for everything from design to manufacturing. Next, let's look at subtractive manufacturing. We have this part of the casing for the impact driver, which is going to require a mold. You can see the mold cavity and core here. In order to validate that the mold can be machined, let's do a material removal simulation on it. We can view the full tool path, from stock to target, and even use utilities like collision detection to validate the tool paths. We can then export those tool paths and use them in the manufacturing process. Once again, Creo provides us with all the tools we need to get our job done, without moving data to and from another software. Now that we've completed the impact driver model, let's add one more off-the-shelf part to test the fit. We will be importing a non-native part file from a manufacturer's website to test the fit. Luckily, with Creo's Unite technology, the model can be imported without any change to its geometry, giving you a faithful representation of imported parts. If we need more information on Creo Unite, or anything in Creo for that matter, we can use the Learning Connector to view tutorial content from PTC right alongside our model. With all of these innovations, it's easy to see why Creo helps so many engineers around the world optimize their workflow, and this is just the beginning of Creo's power. There is so much more to Creo than meets the eye, so the only question left to ask is how Creo will fit into your company's workflow.